Hello, and welcome to Backer Breaks It Down. In this episode, we continue working with exponential models that we will solve using logarithms. And this episode focuses on something called doubling time, which is basically what it sounds like. It's the time it takes for a quantity to double in size. Right? Because eventually, if something's growing, eventually it'll double, right? Okay. So basically, in order to figure this out, we just need to know how long it takes for the new value to be 2 times the initial value. Okay. Now, if you think about this, you would ultimately divide both sides by that a value. So this is what you would end up with. You'd end up with 2 is equal to 1 plus r to the t power. So basically, this is suggesting a formula for what would we do in a non-continuous exponential situation, right? 2 is equal to 1 plus r, that's the growth rate, to the t power. So basically, all of these problems can be set up. 2 equals the base to the t power, okay? That's like the general formula. Our non-continuous base b functions, b is going to be equal to 1 plus r. Our continuous base e functions, we're going to have 2 is equal to e to the kt power. Okay, because remember, if it's a continuous exponential situation, they're going to use that word continuous, and we have to use base e. But the bottom line is, all three of these formulas are essentially saying the same thing. They're all saying 2 equals b to the t power. So what is the base? We need to know that. And then we can create a really simple equation using the 2 equals base to the t power. Okay. So we're going to take a look at 3 scenarios so you guys can see how all of these formulas are being used. So problem 2 says the population of Middle Earth in billions is represented by the function p is equal to 8 times e to the 0.018 t power, where t is the number of years since 2000. In what year will the population of Middle Earth double? All right, so I'm working with doubling time. So of course I'm thinking about those 3 doubling time formulas. The fact that this is a base e function makes me want to use this function over here. 2 is equal to e to the kt power. So I've got 2. This is equal to e to the kt power. Kt is given to us to be 0.018 times t. So there's my 2 equals e to the kt power. And so now I just need to solve this. And I'm going to solve this equation using logarithms. So I'm going to take the natural log of both sides. All right. So when I take the natural log of a base e function, the exponent is free, but the exponent is all that remains when you take the natural log of e to some power. All you're left with is the power. And so here, all I have to do is some simple division. I need to divide both sides by the 0.018 to get t all by itself. So get out my calculator, type this in, and I get that t is 38.5 years. And it says, in what year will the population of Middle Earth double? So this would be the year 2038. So sometime mid-year 2038, the population doubles. Okay, easy, right? All right, so let's check out another doubling time problem. Okay, so let me get my highlighter ready so I can get all the important information. In 2005, Sudan's population was 40.19 million and has been increasing by 2.6% every year. Estimate the number of years it'll take for the population to double. So I am working with doubling time. So is this a non-continuous or a continuous situation? Yeah, that's right. It's non-continuous. And so my non-continuous, I need to know what is b, and this is how I'm finding it. So 2 is equal to 1 plus r to the t power. That is my rule that I'm using here. So I'm going to have 2 is equal to 1 plus r. Well, that's going to be 1.026 to the t power. So this is just me straight up using this rule. Okay, now I'm ready to solve. So I'm going to solve this by using my logarithms. I'm going to take the natural log of both sides. So that's going to give me that the natural log of 2 is equal to, I'm going to have t times the natural log of 1.026. And then to get t all by itself, I would need to divide both sides by the natural log of 1.026. And that's what I'm going to then calculate. So in my calculator, I'm typing natural log of 2 divided by natural log of 1.026, and I'm getting that t is approximately 27. So that's 27 years it's going to take. So notice in this problem, like they gave me the initial population. I don't need it. I don't need to know my initial values in order to figure out doubling time. It's really not necessary. I just need to know what the base of my function is and I'm good. Okay, so like if they give me my initial value, great, that's nice. I don't need it. All right, one more. So in 2017, the population of Spring Grove was 11,000 and it grew to 13,000 in 3 years' time. Okay. How many years did it take the population to double? Okay, so it's like, this is definitely a non-continuous situation. They did not tell me what r was, like how can I figure out what 1 plus r is if I don't know what r is? So I can't really use this formula here. Which leads me to 2 is equal to b to the t power. But like, what is b? Well, b can be found using our change factor formula. Okay, so b is going to be equal to that population of 13,000 divided by the initial population of 11,000. And this happened in 3 years' time. So I'm going to take this to the 1/3 power. And this is going to give me my b value. So let me calculate this. All right, I got 1.057. So now I can finally calculate the doubling time using 2 is equal to b to the t power. I now know that b is 1.057. So there's my b to the t power. And then I'm just using my natural logs to solve. So I'm taking the natural log on the left. I'm taking the natural log on the right. I'm getting that the natural log of 2 is equal to t times the natural log of 1.057. And then I'm going to divide both sides by the natural log of 1.057 to get what t is. So I'm just going to do that on my calculator. And I got 12.5 years. Yeah, that's what I got for this one. Okay, so we just need to figure out what the base of our exponential function is. This required us to use our change factor formula here. No big deal. From there, it's pretty easy. 2 is equal to b to the t power. So that's how you can set up doubling time problems. You need to know what the base of your exponential function is. If they give you that percent rate, then the base is 1 plus r. If they tell you it's continuous, you're using that base e formula. And that's how Backer breaks it down.